basically is about factorization. But okay, well, don't worry. And number one, number two, and number three example is a typical example of the long division of the polynomial. Long division. Let me refresh your memory about long division of the polynomial. So you divide, for example, let's do it the first one. The first one say x squared plus 3x minus 54 divided by x plus 9. The format to perform long division look like that. You open the symbol x squared plus 3x minus 54. You put the top part, let's call it dividend, and the bottom part is divisor, you put it here. And little by little you perform the division, and the answer you put it here in the quotient part. Okay, so now we start piece by piece. You ask by yourself, what is the expression? I need to multiply by x, get the first one, in order to get x squared. Well, it's obvious que es x, because x times x, x squared. And now multiplication this and this. So you did the multiplication this and this first, and this secondly. Entonces es 9x, okay? Now, as all we have the division. Division is the procedure que you multiply and subtraction. So you subtracting, you change the sign of the polynomial like that. Boom. Okay, it's similar, for example, in elementary school, we are doing divided by 5, divided by 2, is 2 times 2 is 4, subtraction, remain the 1. This is the algorithm of the division. Exactly the same, but in algebra, we perform on the polynomial, or binomial, I don't know. Now subtraction, that part is gone. That was the intention, and this part is negative 6x. Now bring down negative 54. Okay, and we continue the process. Okay, how do you know when you stop? When you stop, when the degree of this part is less than the degree of this. The degree of this is 1. Remember, degree is exponent. Degree is 1. Degree is 1. Because the exponent in the x is 1. And degree of the divisor is 1. Entonces, no, we cannot stop. We continue. We continue when the degree is 0. Entonces, bring down 54. And I can see that the next guy is negative 6. Because negative 6 times x is negative 6x. And negative 6 times positive 9 is negative 54. But now subtraction, don't forget, subtraction change the sign. And the answer is 0 remainder. So what is the final answer? The final answer is x minus 6, which is exactly that part, the quotient part. Okay, this is the final answer. Any question? Long division. Practice, let it be. Long division. Clear or confusing? Come on, opinion. Could we do another one?
It's very
No, we have 2 more. We have 2 more. We are doing today. No, I don't know. See, we the entire package. I did number 1, number 2, number 3. You see, in the review we are doing more. Don't worry, be happy. Okay. The thing is, you understand or no? Somebody say something that I don't understand. Let me see. David, you are here or no? Okay, it's clear. Okay. Entonces, no problema. One more. He said que need one more. Okay, no problema. I have 2 more. Two more so far. I guarantee in the review we have more. And what did two, and what did two, and what did two, and what did two. Okay. Okay. Let's do number two. Number two now. Number two is x squared minus 12x plus 32 divided by x minus 4. Let me put in the long division format. Okay. Okay. It's obvious que es x. Because x times x is x squared. I copy using the original sign after I change the sign by subtracting. And this is negative 4. Negative 4. Now by subtracting, you put negative here and positive here. This is cancel, 0, and this is negative 8. And bring down 32. Just bring down. Okay, now is negative 8, no? Because negative 8 times positive x is negative ax. I copy using the original sign. And this negative, negative, positive, 32. But by subtracting, you change the sign. In this case, it's easy, it's plus. In this case, I erase that part, you put minus. Okay, again, it's 0 remainder, boom. And the answer is x minus 8. An equation, long division. In this case, it's easy because the degree on the top is 2, degree 2. And the degree of the bottom is 1. Entonces, one way, pero no in this subject, in another subject, in pre-calculus, we study another way to do this, que is synthetic division. But synthetic division only is possible when the degree at the bottom is 1. Long division is more general. You divide any polynomial, divide by any polynomial. Long division, long division. Everyone follow me? Long division? Yes or no? Yes. Long division. One more example, long division. Wow, I don't like this guy. Delete, 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 delete. Unbelievable. Okay. Okay. Again, let's do it again. Sometimes happen, I don't know why. Okay, I cannot delete. Okay, yes. Oh, yes, 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 delete. Carajo. Well, delete. For the keyboard was deleted. Okay, now number 3. Number 3. Well, number 3 is similar. Y squared plus 10y plus 25 divided by y plus 5. Let's do it. That format. Y plus 5. Let's solve because y. Because y times y is y squared. And y times 5 is 5. Y. By subtracting, change the sign. This is cancel, always happy, and this is 5. 10 minus 5. And bring down 25. Okay, now I try to find the expression or the number in which when you multiply by 5, give me 5y, so look at 5, positive 5. And 5 times this multiplication, this and this, and this and that. That's a 5y and 5y. And 5 times 5 is 25. Okay? And by subtracting is minus, again, 0, 0. And then the answer is y plus 5. long division. Easy, easy. I promise que we continue not now doing another example of the long division. Okay. Any question? No? No? Clear? Do you remember very well this or no? Christopher, it's okay? Espinosa? Christopher, are you there? Answer me. Alejandro? Alejandro? Answer me. Christopher is sleeping. No attendance. No? And okay, Alejandro, yes. Okay. And Sherman Collins? Is he here or no?
Here.
Okay, super. Okay, entonces Rancé dice es clear. Okay. I believe. Okay. Okay, it's clear. Now the most important moment. Okay, factorization. So we're discussing factorization. Factorization is extremely important in algebra because we have to apply several times factorization to simplification or to find solutions. Okay, entonces es super important. We study now and we're using here in the subject and also in another subject in college algebra, in pre-calculus, in calculus. Frequently the student apply factorization, okay? Entonces, this is important. I want to explain, we have different cases and you have one specific strategy to apply factorization. But don't worry, little by little I explain different cases. And finally, we summarize everything. What is the best strategy to apply factorization in any algebraic expression? Okay. First of all, let me try to understand what is factorization. So everyone is clear when you are doing multiplication. Multiplication 5 times 3 is 15. Okay, in that direction, this process is called multiplication. But in opposite direction, it's called factorization. Okay, in other words, is you take one number or expression. I explain using numerical example, but after we can see algebra variable. In other words, it's a process in which you take 15 and break it down in prime factorization. So it's a prime. Prime means prime numbers is a number by definition is only possible divided by itself or 1. The collection is infinity. Is the most typical prime number is 2, 3. Can we use it? No, because it's infinity collection. But the most typical you need to remember 5, 7, 11, 13, 17, 19, 23, 29, bam, 31. This is infinity, okay? So basically the process of the factorization is break down this any number and that number gets the small piece of the arithmetic. And by the way, the factorization is unique. For example, you have 12 and I doing the prime factorization. Okay, what is the procedure? In my opinion, there are many ways. Okay, you start for the first prime number. And this number gets 12 as even number because any number doesn't matter, gets too low number 4, 5, 7, 8, 1, 2. You see the last digit, gets 2. See the last digit is even. this number is here. So you start by 2 because you break it down 2 and 6 because 2 times 6 is 12, and again 6 is even to 3. So what is the factorization? Now the factorization for the 12 is 2 times 2 times 3, or 2 to the second power because repeated 2 times 3. Either way, I prefer that way. Entonces no, entonces wait. Another two say no. I disagree with this idea because I know que 12 is 4 and 3. Okay. And 4 is prime, no. 4 is composite number. Entonces you break it down into 2 and 2. Entonces you see que again we get the same result, 2, 2 and 3. 2, 2 and 3. That means que the factorization and prime number is unique. And this is the fundamental problem of the arithmetic, no? The factorization, any number using prime collection, prime number is unique. It's only one, regardless the way you are doing the operations. You break it down different like me, but finally we get the same answer like me. Okay, I put this elementary example, but they are a lot more complicated. Okay, this is the idea in arithmetic. And what about algebra? Well, algebra is similar because, for example, you have variable. Suppose that we have x to the 4 power and x to the 6 power. No? But actually, it's the same. This is like x 4 times, no? And this is 6 times. 1, 2, 3, 4, 5, 6 times. Entonces now I define, because the factorization is condensing something. Bueno, break it down, condensing is, look, I see que the GCF, what means GCF? GCF means greater common factor is in that case, I can see okay, we have 4x here, and we have also 4x. So the greater common factor between x to the 4 power and x to the 6 power is x to the 4 power. It's the number of the variable that both expressions share. This is super easy because I remember that you take the smaller exponent. Okay, a smaller exponent. This is in the GCF. We study after another thing is least common denominator. No, least common denominator is different, but no now. Okay, let's move on to the example in which you factorization using GCF, greater common factor. I want to explain in detail. Any question, let me know. This is the theoretical part for the factorization, prime number, and the idea behind GCF. Okay, no. Okay, this is completely no important. Okay, let's pay attention and make a zoom. I suppose that everyone has received this package, no? We are doing number 40. 4. Number 4 say 40 x to the 7, y to the 8, plus 72, x to the second, y 6, plus 72 again, x to the 4 power, and y to the cubic power. Okay, entonces, what is the question? Well, the question is factorization, factor out using GCF. So the greater common factor. The first thing you should do is find the GCF. Find the GCF between this guy, and this guy. Okay? Entonces, I want to analyze step by step. You analyze first numerical part. So I focus in the number. By the way, 72 is repeated. Nice. I love it that because I need to do one time. So you break it down 40. and 72. Both are even number because ending in 0 or in even number. The last digit give me the characteristic. It's even when any number doesn't matter the long of the number ending in even or 0. Okay, entonces divided by 2 is 20. Divided by 2 is 10. Divided by 2 is 5. Done. 72 divided by 2, 36. Divided by 2, 18. Divided by 2, 9. And 9 not divisible by 2 anymore is 3. And 3. Okay, so I try to see what is the common factor. What is the common factor? Let me see. I saw that both number 40 and 72 share 3, 2. 1, 2, and 3. That's it. Because 72 have 2 more 3, but 40 have no 3. And 40 have 5, but 72 have no 5. So the conclusion is the GCF n between 40 and 72 is 2 times 2 times 2. Es a factor. Entonces, no 2 plus 2, no. Es a factor. Es multiplication. Entonces, 2 times 2 is 4 times 2 is 8. It's 8. Okay, let's analyze the variable one by one. For example, the x part, GCF, and the x part is x to the 7th power, is x to the 2nd power, and x to the 4th power. I explained before. Can you take the smallest one? Okay, because it's the common part. And the y part, the GCF and the y part is y8, y6, and y3. So obvio que es y3. Okay, entonces, professor, what is the GCF? The completed GCF. The completed GCF is 8, x to the 2nd, y to the cubic. Everyone follow me so far? I don't finish. We are in the middle of the process that we determine the GCF for any expression, one by one. Okay, now ready to factor out. Factor out what? The GCF. I put outside a x to the 2nd, y to the cubic. Y open one parenthesis. Okay, because this is a factor that I put outside the factorization. Entonces, inside the parenthesis, we put the remaining part. For example, 40 divided by a is 5. Okay, there are many ways to do this. Or what is the number you multiply by a, give me 40? Is 5. We have 7x. And out I put 2. No, x, 7x. You know, it's x times x times x times x times x times x times x. No, how many? 1, 2, 3, 4, 5, 6, 7. And you factor out 2. Look at that. x2 is x times x. That means that this either you put outside and stay 1, 2, 3, 4, and 5. It's not necessary doing this way because it's easier. It's your subtraction is 7 minus 2 is 5. And likewise, a minus 3 is y to the 5th power. Okay, do you see that? And let's do it one by one. Let's do it one by one. Okay, it's 72 divided by a is 9. Plus 9. Plus 9. Entonces, we have x squared here. And you factor out x squared. Exactly the same. So we have no x in that part. Because the only x that we have, I put outside the parentheses. And 6 minus 3 is 3. Plus 9 again. X to the 2nd, because 4, I put 2 up. And y to the 3rd, complete out. And no y to the 2nd. Okay, now I select the option. Let me see. I suppose que es A, no? Es A. Yes. The answer is A. Okay. Did you see or no? Question. Guys, this is important. Super important. Question. Come on. Come on. Come on. Answer me. Everything clear? Sum up, sum down.
It's all clear, Professor.
Okay. Okay.
Tricky part is that when we sit down and do the examples later, we have to remember everything that you said, which is hard to do.
I know.
You need to practice a lot.
Exactly.
I love the way Alex just keeps on giving you more and more and more to help you get your skills great.
This is the intention. Exactly the intention. So this just that part you see in your life before. Now you don't remember very well. Well, you remember something. You remember details, maybe. No detail. You remember at least the music, but not the lyric. Now you refresh your memory and practice using Alex. This is the idea. Okay, let's do it. Number 5. Number 5 is 6 x to the 12 minus 12 x to the 9 plus 18 x to the 6 minus 24 x to the 3rd. Okay. So my goal first is find the GCF between 6, 12. I don't care the sign. The sign is not important. 18 and 24. Okay. For doing that, we can use in intuition. I suppose get 6 because you know 6 is 6. 12 is 6 times 2. 18 is 6 times 3. And 24 is 6 times 4. But this is intuition, and sometimes the intuition doesn't work very well. So now the systematic way is you take any number, break it down in primary factorization, and you select the common factor. This is 212, this is 2, 6, this is 2, 3. Yeah, I can see, wow, what is common here? I don't see. I suppose que 2 is common, look. I suppose que 3 is also common, look. And that's it. Because 6 is finished, I take every factor of 6. The conclusion is okay. 6 is the great common factor in the numerical part. And the variable part is super easy because I explained before, okay, you take the smaller exponent, okay, the smaller exponent is x to the 3rd power. Therefore, the general great common factor in this example is the general great common factor in this example is, no parenthesis, is 6x cubed. Numerical variable part. Okay, do you follow me? Do you understand this? Okay, now the last step. You factor out that guy. Factor out that guy. That guy is 6x cubed. Open parenthesis. Inside the parenthesis remaining part. See, this 6 I put out. We have 12 minus 3 is 9. This is 2. Because in my mind working like 12 is 6 and 2. And this 6 out, put out to say stay only 2 x to the 6th power because 9 minus 3 is 6 plus 3 because in my mind working like a 6 times 3 x to the 3 because 6 minus 3 is 3. And here exactly the same, 6 and 4 and minus 4. No x because I factor out 3. It's exactly the same amount I have the last term. Therefore, final answer. I try to find what is the option. Okay, I suppose que es 0. You see. You let me know if I am select wrong, guys. Because sometimes I am not good to selection. I am good at doing the problem, but now when I finish the problem, I have no more energy to selection, no? Okay. Everyone is agree with the selection C or no? Yeah, I suppose yes. The out part is 6x cubic, x9 minus 2. Yeah, it's the answer. Good. GCF, factorization using GCF. And by the way, factorization using GCF is the first technique we studied, but it's the first technique that we're using in our strategy. So the first thing you should do is find GCF and factor out. Sometimes no GCF or no. Yes, always we have GCF. Suppose what is GCF between? Look, this is confusing. 5 and 3. It's a prime number. What is the GCF in between 5 and 3? Well, the GCF is no, yeah, it's 1. Always is 1. When you have no, it's because the GCF is 1. Keep in mind this because in the Alex, sometimes it's find the GCF. No, professor, no GCF. Always is 1. Because 1 is the magic number that everyone have. Let me see 6. 6 is number 6 example. Y to the 4th power minus 47 YW6 plus 7 QBWA minus 11 Y4W6. Let me see if I copy right or no. Let me make it zoom a little bit. Y4 minus 47 YW6 plus 7 YQBWA minus 11. Okay. In this case, the number that participate in the game is the GCF between 1, get this coefficient, 47, 7, and 11. Wow. Remember, I don't care the sign. The sign is not important. So we have no common because 1 is the special number, no? No primary, but it's a special. 47 is primary. 7 is primary, and 11 is primary. The GCF is 1. No GCF. Or 1 is the same. Entonces, in the numerical part, in the Y part, the GCF is 3. Okay, entonces the total GCF is 1, que es invisible, in the numerical. And the Y is only 1 Y, no? Sorry. This is 4, this is 1, 3, and 4. And W, we have no W, because the first guy have no W. The W is no common. So common, so what is the idea for the common one? The common X share the same. See, it's missing 1 term, there is no common. So the only GCF in our problem is Y. That's it. In the story. Okay, now the GCF is Y. Only 1 Y. And you factor out. You factor out 1 Y. Y out, open new parentheses. You have Y to the 3rd power because we have 4, and you split in 3 and 1. Minus 47 can stay the same, W6, because the only Y we have in the second term go outside. Plus 7, Y squared, WA, the A stays the same. Minus 11, Y cubic, W6. I suppose that we cannot do any more. Okay, entonces es obvio, the correct answer I detecting is A because you factor out only 1 Y, get the great common factor. Any question? What part is confusing? Everything is clear. GCF is clear. Entonces, let me repeat one more idea. let me repeat one more idea. When you face one problem of the factorization, the first technique you must using is GCF. Find the GCF. Okay, no GCF or one. It's the same, no? Okay. Entonces we continue another technique. Okay, another technique. Entonces we study now the second technique, que es factorization by grouping. Okay, factorization by grouping. By grouping is similar to the GCF technique, but a little bit, because you find the GCF but by couple. So, okay. Number 7 now. Look, number 7 say R cubic plus R squared plus 5R plus 3. Plus 5, F5, sorry, F5. No 3, F5. Entonces, for example, si I ask by myself, what is the GCF in this entire expression? No GCF, que es equivalent to say que es 1. Entonces, it's not useful. Because we have 3R, 2R, we have 1R, and this we have no R. We have 5 here, but no 5 here, no 5. Entonces, no GCF. Entonces, there is 1. Entonces, when there's 1, it's completely useless. No important. However, if you analyze another thing, you analyze by couple. This couple and this couple, que no necessarily is in this direction. Maybe it's another direction. Okay, you select the first and the second, and you select the third and the last. See, it doesn't work. You see how you know the word doesn't work. So you maybe select another arrangement. Okay, but in this case, I suppose it's good. Then you find the GCF, you find the GCF in the red part only. Ignore the blue part. And you find the GCF in the blue part and ignore the red part. It's obvious that the GCF in the red part is R squared. Some people confuse it. No. Some people confuse it and say, no, professor, no, it's R. No, you are wrong. Because it's the greater common factor. I agree with you. This is R cubic is R times R times R, 3R. And R squared is R times R 2 times. Then it's obvious que common factor is R, pero not the greater common factor. The greater common factor is the big amount is common. So the big amount is common is R squared. It's clear? Entonces you factor out. You factor out the greater common factor in the red part. Open parentheses. So we have R plus 1. Because we have R cubic, is R times R times R. You factor out 2, stay only 1, and R squared completely out, stay 1, que is the common factor. So what is the common factor in the blue part? Well, I suppose it's 5. It's easy to see. 5 is common. And you factor out 5. You have R plus 1. Similar idea, right? And this is the most important moment. Look. This guy and this guy is the same. See, we select the couple. You find the GCF, nice. And you don't get exactly the same binomial, R plus 1. Depending on the example, not necessarily it's R plus 1. See, you don't get the same, your arrangement 1 and 2 and 3 and last is not good, and you need to modification. Okay, but in this case it was nice. In this case, you see it's the same, and you factor out. Let me use in the black color. You factor out one more time. R plus 1 out, and open the last parenthesis, and inside the last parenthesis we have R squared plus 5. Where come from R squared? Well, it's this guy, and 5 is this guy. And R plus 1, I think it's common. That is the reason I put outside like a common 1 time. And what is my final answer? Well, my final answer is this factorization. This is factorization by grouping. Factorization by grouping. By grouping. And one clue to detecting easy case by grouping is when you have 4 terms. So when it's a polynomial que contain 4 terms. 1, 2, 3, 4. The original problem contains 4 terms by grouping. Question by grouping. Do you remember or no? Totally lost? Good. By grouping factorization. Okay. 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 Number 8 now. Factorization by grouping. Wow. Okay, number 8. Number 8 is t squared plus 80 plus 90 plus 72. Similar situation happen, no GCF. Well, that's useless. When you select a couple, I have no idea what's the best way. However, I select the first and the second, and the third and the last. See, it doesn't work. How do you know it doesn't work? Because the last part, see, you see that the binomial is not the same to say this arrangement doesn't work. Because the GCF in the red part is t. And we have t plus a. When you factor out t, I put the parentheses, okay? And here is 9 because I know very well that 72 is 9 times a. Okay, entonces 9 es a common factor, t plus a. Where come from this a? Bueno, this a is this a. Entonces now I am happy. Look at that. Happy. Because this factor is the same. That means our arrangement works perfectly. My recommendation is select the first and the second, and the third and the last. Si it doesn't work, so you manipulate another way, you know, but I suppose que 99% of the case working in that direction. The t plus 9. Do you understand where I come from t and 9? Sure or no? This is the answer, I suppose. Let me select, help me guys, again. No good. I don't select the 7, I forgot. It's this, no? I suppose que, well, I don't remember. Number 7, I don't remember. Okay. Follow me? It is. Okay. Angélica say que number 7 is A. Thank you, Angélica. Angélica say que number 7 is A. Okay, Angélica. Es B. No for A. Wait. En A es D, ¿no? No. No es A, you are right. Absolutely perfect. This is this. Because of plus. Pues select minus here. This is wrong. And 7 is A and A or no? I don't remember. Okay, but not important. You have in your notebook, no? You copy. Could you help me this to select or no? Or you don't copy anything? You watching the video and that's it. You don't copy anything in your notebook? Let me try to understand.
Always copy while you're doing the lesson and
Okay.
not on the video.
No, it's okay. I draw to you, so you say I believe. Jasmine copy, and the rest of the student copy or no? Okay, some people say, no, I don't want copy because I'm watching the video. I copy after, no, never copy. I copy in my brain. I don't know. This is the college. Yes. What means yes? Angelica. Angelica said yes, but what is yes? You copy or you don't copy? I copy, okay. Angelica said I copy. Okay, number 9. Number 9. Number 9. Number 9 say x cubic plus 3x squared plus 6x plus 18. Okay. GCF, how do you know? By grouping. How do you know? 1, 2, 3, 4 turn. It's logical. It's indicate case by grouping. Let me select in this order. This and this, and this and this. What is the GCF in the red part? Well, the GCF in the red part is x squared. X plus 3. What is the GCF in the blue part? We suppose que 6. Factor out 6, que es the GCF, x plus 3. Now, fantastic. X plus 3 is the same. You factor out x plus 3. And in the last parenthesis, I open the door, is x squared plus 6. Okay, and this is the option plus 6. The option D, no? Eddie? Hey, guy, let me know if I am doing well or not. The selection. Yes or no? Create a common factor. Factorization by grouping we are doing now. Okay. We are doing factorization by grouping. Grouping is applied when you have 4 terms and is no greater common factor in the whole expression. So you select by couple. By couple. Okay. Grouping. Easy. Okay. One more. Factorization by grouping. Number 10. Is UB minus 7U plus 5B minus 35. Okay, let me try with this selection. The great common factor in the red part is U. Open the parentheses, we have B minus 7. The great common factor in the blue part is 5. Because I know that 35 is 5 times 7. So 5 is common. Factor out 5, B minus 7. Okay, nice. B minus 7 is common factor again. B minus 7. Open the last parenthesis, U plus 5. This is my answer. Okay, now, who helped me to selection? What is the option que corresponde? What is the option? Let me see, what is the option? Nobody, help me. B minus 7, U plus 5. I suppose que es... Exactly. Es B. Angelica and Jasmine. Answer me. Okay. Grouping. Factorization by grouping. Any question? Factorization by grouping. Okay. Let me erase totally the board. And let me upload the second page of this package. What is that? Practice for 3. I suppose it's this. Yes, it is. Okay, boom. Okay, this is the next page, page number 2. We have 2 more examples. of the grouping, I guess so. Okay, number 11, say 6r squared plus 27 ry minus 2xr minus 9xy. I have no idea. I try the traditional way, but maybe work or doesn't work. So you arrange in another. Okay, the great common factor between, and the red part is, I suppose que es 3. The numerical part is 3. Because 6 is 2 and 3. And 27 is 3 and 9. Okay, it's also 3 and 3, but we have only 1 3. So 1 3 and 1 r share. Now you have 2r plus 9y. Okay, this is the conclusion in the red part. And the blue part, what is the common factor? I have no idea. I suppose that the common factor is x. It's x. It's the only thing is repeated. Common. But you factor out no x. You factor out negative x. Why? Because I can see that both are negative. There are no reason. Remember, my goal, my target is to get one binomial similar to this. So es x. So we have 2 positive r, because you factor out this negative and this x outside. And so take 2r, because okay, one efficiency way to verification okay, everything is okay or not, you multiply this and this, is 2xr negative, so we are doing well. Plus, again, plus 9y. Okay, and this binomial is the same. Factor out one more time. Open the last parenthesis, 3r minus x. Done, final answer. Okay, help me to selection what is the correct option. 2r plus 9y, 3x minus 3r minus x. 3r minus x. Should be this or not? I guess so, right? I select correct or incorrect? I say, wow. Yes, you're right. You're right. This is wrong. No. Thank you. Okay. Okay, one more of the factorization by grouping. And that's it. That's it, grouping now. Okay. Is 12 is a number 12. It's a coincidence. Number 12 example. I start with 12 minus 6y minus 2x plus yx. Well, again, I select this. I don't know if it works always or no. I don't remember. Okay, the great common factor in the red part is 6. You have 2 minus 1. The great common factor in the blue part is x. But the challenge is I factor out positive x or negative x. I have no idea. I suppose using my intuition get minus x. So we have 2 minus y. See, yes or no? Okay, let me check it just in case you make a mistake or not. Negative x times 2 is negative 2x. And negative positive xy. Super. This is correct. I am happy now because 2 minus y is the same. You factor out 2 minus y. Open the last parenthesis, 6 minus x. Done. Done. Now selection. I need help for the selection because always I make a mistake. And not intentionally because I don't see very well. Okay. What do you consider is the option? 2 minus y, 6 minus x, 2 minus y. I suppose is D or no? No? Is D?
D is correct.
D is correct. Okay. So far, you understand very well grouping, factorization by grouping. So far, we studied, let me summarize a little bit, we studied number one technique, is GCF. So you find the GCF and factor out GCF. And the second one is by grouping. Okay? When you apply GCF always, when it's possible, of course. When the GCF is 1, no, it's impossible. And grouping, basically, when you have 4 terms in our algebra expression. Let's start the most complicated part now. Case trinomial. Trinomial is complicated. Why is it complicated? Trinomial is three terms. Let me introduce the idea to the trinomial. Factorization trinomial. It's the most complicated thing in algebra. And some students never understand this trinomial. Factorization. Trinomial is 3 guys, no? 1, 2, 3. But we have different kind of trinomial. This is important that you identification what kind of trinomial. We have, for example, the regular trinomial, that is very straightforward. Suppose after we are doing the example, because my goal is to you identification the trinomial. So the first kind of trinomial that we face is a regular. Regular is, for example, so you have x squared plus 4x plus 4, okay, 2, okay. Suppose x squared minus 5, x plus 6, something like that. It's trinomial 1, 2, 3, trinomial, nice. And the factorization, when it's trinomial, always you open 2 parentheses. You put the name of the variable as x, but in other cases, no x, it's maybe it's s, u, y, r. And you try to find two number. Okay, when you multiply each other, give me 6, okay, it's this number. You have maybe 2 combinations, 6 times 1 and 3 times 2. However, this number, 3 times 2, is 6, okay? When you adding all subtraction, maybe both possibility, give me 5, get that number. So this 6 is this 6 in the original, and this 5 and this 5. This is the key to open the door. You copy 3 and 2, and you put a sign. In this case, negative both. And negative because negative 3 and negative 2 is positive 6, like the original, and negative 3 and plus negative 2 is negative 5, like the original. Okay, this is the regular. We have another case more complicated, very complicated case, special trinomial, or some people call it complicated trinomial, whatever. It's when the coefficient here in the front is no 1. Look, this is regular identification. It's regular when the coefficient here is 1. And when it's 1, therefore you omit this 1. But suppose that you have 2. Leading coefficients is 2, or 3, or 4, or 20. This is special. And this is very, very complicated, in my opinion. Now, I don't want to explain now. And the third one is easier. This is easy. It's perfect square. Perfect square. trinomial. Okay, entonces perfect square trinomial is, for example, when you have that situation. Look, suppose x squared plus 4x plus 4. Bueno, I have no idea. I have no idea. I suppose que es regular, professor, porque the professor explained that when this one here is regular. Okay, entonces I open the parenthesis. This is x, and the combination is 2 and 2 because 2 times 2 is 4 and 2 plus 2 is 4, and the sign is plus. Okay, a perfect square because in this special case, the factors are twin brother, and we can condense it like that. Okay, x plus 2 squared. After I want to explain in detail, in your moment, let me see another example, another elementary example, que es perfect square. And you detecting using one rule, suppose this. Okay, I have no idea. I open two parentheses because I believe que es regular. Okay. And the combination is 5 and 5 because 5 times 5 is 10, is 25, and 5 plus 5 is 10. Wow, in this case minus. Okay, the important sign is this sign, the first one. You see this sign is positive, it's positive off. See this sign is negative off. And the perfect square, in the regular no. So see, this is x minus 5 squared. So do you understand? Okay, the thing I want, can you understand so far? This is complicated, very, very complicated, I promise. Is that we have three kinds of trinomial, and this is important, identification. Because when you identify, your idea is more clear about the strategy that we use. Entonces now, I want to practice a little bit, regular. And when you feel strong in regular, so we start special. So let me try 13, because 13 is a classical example of the regular. Okay, is x squared plus 7s plus 12. Okay, regular, of course, it's regular because coefficient here is 1. So I open two parentheses. You put s, and you try to find the key to open the door for this trinomial. Okay, I try to find two numbers that multiply each other, give me 12. And somehow, when you adding on subtraction, give me 7. I suppose it's 4 and 3. Okay, and the sign is positive. It's positive because this sign is positive. When this sign is positive, okay. Let me analyze the problem of the sign, but not too in detail. When this sign is positive, okay, this is the, let me call one name. This sign is the first, and this sign is the second. But when the second sign is positive, that means that we have the same sign. So plus or minus. The sign is plus or minus. When the second sign is negative, no, completely different. But bueno, in other example you see. When it's the same, what option you select? Plus or minus? I plus. Why? Because the first sign is positive. Because the first sign is plus. That is the reason the plus. And this is obvious. It's obvious, no? Si es plus, es plus. Pero no. Okay. Let's analyze. Okay. Entonces, to find the key to open the door, I recommend that you take that number, que es 12. And you analyze the possibilities, the factorization. O sea, 12 is 12 and 1. 12 is 6 and 2. And 12 is 4 and 3. No more possibility. And when you adding and subtracting, plus or minus. And you adding a 13, when you subtracting is 11. Doesn't work because my goal is 7. And 6 and 2, no, doesn't work because it's 8 when you adding, when you subtracting is 4. No, no good. In this case, 4 and 3, when you adding is 7. I got it. It's 3 and 4 and 3, the combination. Okay, in this case was easy. So you use intuition. Intuition is fantastic. However, sometimes the intuition doesn't work very well, and you need to apply that rule. So you break it down. Let's do it. Another example I promise to explain in detail, one by one. Do you understand the idea? Confusing. Too many details. Saying different. I don't know. Have an idea. Don't worry. Let's go to the 14. Maybe 14 illustrate a little bit more clear, clarify step by step. U squared minus 9u plus 14. Regular trinomial again. How do you know? Because the coefficient here is 1. Coefficient is 1 regular. Open two parentheses. You put the name of the verb, get you. I do try to find the key to open the door. 14 and 9. Two numbers can multiply, give me 14. Maybe 7 and 2, no? And 7 plus 2 and 9. Exactly, this is the idea. 7 and 2. Okay, just in case, one corner of the piece of paper right to verification. 7 times 2 is 14. And 7 plus 2 is 9. Maybe plus or maybe minus. Addition or subtraction. Sometimes working subtraction. But in this case, no. And analyze the problem of the sign. The second sign is positive. Look at that. Si es positive, I know que the sign is the same. Si es negative, it's different. Si es plus, it's the same. What is the same? Plus or minus? It's minus. Why? Because the first sign is negative. This is the clue. Okay. I understand. However, I want to check it. Yes, mandatory checking. Okay, we are doing the opposite process in opposite direction. Well, it's easy. You apply FOIL. If you want to prove that this factorization, when you multiplication, we come back again to the original trinomial. Let's do it. U times u squared. U times negative 2, negative 2u. Negative 7 times u, negative 7u. And negative 7 times negative 2, positive 14. Because negative times negative. And when you combine like term, is 9, negative 2 and negative 7 together, plus 14, and we come back. So our factorization is fantastic. It's a verification. So now in the 13, the correct answer was B, bang, and the 14, the correct answer was D, no? I guess so. Everyone follow me? Do you see that sometimes, not always, give me the possibility of the prime? Why? Because don't expect any trinomial is possible with factorization. It's similar to the number, for example. We have a number prime, is for example 23. Do the factorization 23. No. 23 is prime number, entonces the factorization is just 23. That's it. Okay, we cannot. Entonces in the algebra happen similar situation. So no all the collection of the trinomial is possible factor. Therefore, this is called a prime trinomial or prime expression in general, not necessarily trinomial, binomial. Because one expression gets impossible factorization is called a prime. Okay, let's do it number 15. 15 say, okay, x squared minus x minus 6. Okay, again it's regular because the leading coefficient is 1. Therefore, immediately I open two parentheses. You put the name of the verb que es X. Y I try to find the key que open the door. This is the most complicated part. Well, 6 is no big deal. Because 6, the only possibility we have is 6 times 1. And 6, the other possibility we have is 3 times 2. When you're adding that number, it's 7. When you're subtracting this number, it's 5. No, doesn't work because I need 1 here. Negative 1. And 3 plus 2 is 5. And 3 minus 2 is 1. Boom. This is my combination. Okay, open the door. 3 and 2 is okay. Doesn't matter. You put 3 here, 2 here. I don't know why in my brain I want the bigger number in the first place. But no. It's a factorization. And it's a perfect commodity. Say some students say, no, I don't like this way. I like this way. 2, 3. It's perfect. Okay, so you put the corresponding sign, of course. But in my mind, working perfectly when you put the bigger first. Okay, the second sign. Ooh, the second sign is negative. That's me interpretation. This is different sign. So we expect no plus or minus. No. One guy is positive, another guy is negative. And who is positive, who is negative? Well, the rule is this sign, get the first one. The first sign is always the sign that you assign directly to the bigger number. Greater number is negative. 3 is negative. 3 and 2, what's the bigger? 3. And the other is positive. Okay, adjust the sign. But I want to make sure can do it well or not. Therefore, foil. The foil is checking part. Okay, this is my final answer, or my potential final answer. I need to verification que es correct or incorrect. Therefore, you foil this answer. You foil. You foil. How you foil? Well, first, x times x squared. First, outer is 2x positive. Inner is minus 3. And last is minus 6. Entonces, the only thing you should do is combine outer inner. Because first and last stay the same. Entonces, x squared, and this is 2 positive, negative 3 is minus x, only 1. Minus 6, and we come back at the beginning. Entonces, our factorization is perfect. Que by the way, is 15 is the option. Is option D. Okay, guy. You see, well, some students say, no, professor, it's different order. I don't care the order. I know very well that the factorization x minus 3 times x plus 2 is equal the factorization x plus 2 times x minus 3 because the multiplication is completely independent of the order, right? What is the difference between multiply 5 times 3 and 3 times 5? No difference. The answer is 15. So you can interchange that. You need to be aware because sometimes in the solutions, the student or the teacher get doing copy in different order, but I don't care. It's totally irrelevant, the order. Follow me or no? Multiplication. Okay, I promise when I finish 18, I will do a big summary of the sign problem. Okay, it's a little bit complicated. It's the most complicated. You master this, you have no problem. Jasmine, you say something? No? Okay. Okay, now 16. Let's do it 16 now. Okay, 16. Oh, something like that. Boom. Erase that part. Okay, now I want to copy 16. 16. Guy, this class is easy. But the only problem is intensive. We are going too fast. This is the highway. Okay? I understand this. Okay. Okay, I understand. Now again, classification in my mind is regular. Okay. Now you open two parentheses. Put a name of the variable and try to find the key to open the door. 21. Well, it's easy because 21 we have only two possibilities. 21 times 1 and 7 times 3. And 7 minus 3 is 4. So this is when you adding a 10, but I don't care when subtracting a 4. Okay, so the combination is 7 and 3. Remember, I like this way. Put it bigger in the first factor. Doesn't matter the order, but it's okay. This sign is negative. That means different sign. Who is positive, who is negative? This is the sign of the greater number. This is positive, says this is the sign of 7, okay, the big number, bigger. Plus minus. Done. We are doing in 2 seconds. Okay, now, just in case, to make sure you foil. In this case, it's not extremely important checking, but in the special, yes, because sometimes it's confusing the sign. In this case, super straightforward, but in the special, no. Okay, so now you foil. X times x is x squared. X times minus 3 is minus 3x. 7 times x is plus 7x. And this is minus 21. And negative positive sign and negative 3. When you combine this guy, this is plus 4, minus 21, exactly like the original. Okay, so now selection. Who helped me do selection? What option is correct in 16? What option? Tell me.
Option C.
Option C. Yes.
Professor, it's very hard to see the little numbers. Maybe when there's so much print on a page, maybe the professor could do it like a half a page at a time so we can see it clearer.
What do you want to explain? Ask me specific.
I'm having a hard time seeing the numbers on my computer, on the paper. I'm saying is that maybe if the professor could blow it up to zoom in.
Oh, okay. Like that is okay?
No.
No?
What I'm saying is when it prints, if you print a half a page of each example on a whole page, it will double the size.
You can. I send to you the PDF format. No? So you want to see more clear? I print here.
No, I can see it on my paper. It's just hard to see it on the computer.
Oh, okay. Entonces, I don't know. A ver, si I make it.
Thank you.
Okay.
Thank you. Perfect. Thank you.
It's good. Okay. Entonces, you understand que, pero the problem is when I make a zoom, I don't see the other part, no? But it's okay.
Oh, okay. Forget it. We'll follow along on the paper. It's like a little confusing going back and forth between the computer and the paper. No problem.
David, you have laptop or big?
I'm sorry?
Do you have laptop or you have big computer?
I'm on a Mac. I'm on a big screen.
Ah, you have big screen. Okay.
Next class, I'll try it on a smaller screen. Maybe I have a few computers here. Maybe the other screen will be better.
I suppose,
no
yes.
No problem.
Okay. 17 now. For doing 17, I suppose I need a little bit help. 17 is x squared minus 2x minus 80. It's a regular, okay. Again, open two parentheses, the variable is x. I try to find the key to open the door. I need two numbers. Can multiply, give me 80. So 80 is have a lot of factor. 80 times 1, 40 times 2, 20 times 4. Pero the most important is que adding or subtracting give me 2. Okay. Entonces, before start the long way que I explain, is break it down, adding and subtracting. You need to use intuition. In your opinion, what is the combination? What is the combination? Two numbers can multiply each other, give me 80, and when you adding or subtracting, give me 2. No idea. No idea. You're looking for the ceiling, and you ask to God, God, help me to find the magic number and open the door. No?
Can we do this on a calculator?
Of course you can, anytime. In this subject, we can use a calculator anytime.
But I'm saying is what do you press on a calculator to factor out the 80?
Bueno, 80 is you divided by 2. Juan Gómez say the combination, professor, is 10 and 2. And 8, sorry. Because 10 times 8 is 80. And somehow 10 minus 8 is 2. I don't care the sign. The sign is not important. The important is find the combination that opens the door. And you adjust the sign after that. Okay, good. Okay. The systematic way is 80. David, look. You is 80 times 1. Is 40 times 2. Is 20 times 4. Is 10 times 8. I suppose we have more combination. I don't know. You adding or subtracting. 81, 79. Now, nothing. Doesn't work because my goal is 2. 42, 38. No good. 24, 16. No good. 18, and 2. Wow, I got it. Okay? This is the idea. Oh, intuition. In your mind, you separate 80 and different factors. Can multiply, give me 80. And you adding or subtracting. Okay? I put it schematically in the board like that. However, sometimes it's not necessary doing this because you using your intuition. No? What about the sign? What do you think about the sign? This is the most important thing, at least for me. Now you find the combination. Okay. 10 and 8 work. Why supposed to work? Because sometimes it doesn't work. Entonces, I am looking the sign in that order. This is my second sign, no? This is my second sign. When the second sign is negative, we expect different sign. So we have plus minus or minus plus. And the first sign always indicate the sign of the bigger number, que the bigger number is 10. Entonces, negative is 10 and 8 is positive. Pero no, I need to check into verification that this factorization is good. FOIL, x times x squared. X times a positive is plus ax. Negative 10 is negative 10x. And negative 10 and positive 8 is negative 80. And you combine this guy, we have x squared, bring down minus 80, and this is negative 2. Exactly like the original. Look at that. Therefore, this answer is correct. Do you understand or no? Please, let me know. Let me know. To more efficiency in my work, I need to know if you understand or no. Maybe, I don't want to change your mind. So you are doing in another way, another teacher is playing another way, and this way you understand much better, you can use it your own way. I explain my own way, because there are different ways to see that. So say, what is the shortcut, in my opinion? You analyze the second sign. The second sign is positive or negative? It's negative, so we expect different sign. What sign is positive, what sign is negative? Negative, in this case, the sign assigned directly to the bigger number, and positive is different, it's another number. Okay, so what is the answer? What is the answer? It's negative 10 and positive 8 is this. In different order, but it's the same. And then, well, okay, let's do one more. And after that, we stop to summarize everything in the regular trinomial. Stop. Okay, one more 18 and stop. Okay, stop. 18. Now 18 is R, the variable, plus 2R minus 24. Okay, it's again regular. So everything in this part is regular. Even in that part is regular. And we start here special. Special not today, of course. So now open two parentheses. You put a variable que es R. Entonces, what is the key que open the door? Two numbers que multiply, give me 24. And addition or subtraction, give me 2. Okay. Do you see or no? Do you see or no? No?
Yes, thank you. It's better.
What is the combination? What is the combination, David?
I think it's 8 times 4.
No, 8 times 4 is 32, not 24. I need to find two numbers. Look.
Oh, right.
24. So two number multiplication. Bam, bam. Multiplication. Maybe the first combination is 24 and 1, no? It's obvious. Another combination is 12 and 2. Another combination is 8 and 3. Another combination is 6 and 4, right? When you add and subtract, it's 25, 23, no. 14, 10, no. 11, 5, no. 6 and 4, when you adding is 10. When you subtracting, is 2. And this is the combination word. Look, there's 2 here.
Oh, right.
Entonces 6 and 4, doesn't matter the order. You put 4 or 6 or 6 or 4, doesn't matter. Y the analysis of the sign say que this sign is negative, that indicate different sign, but...
So the first one is positive, the second one is negative.
Absolutely perfect. Okay, now I leave it like that. No. Mandatory checking. The trinomial is tricky. In this case, we see an elementary example so far. But I promise, I guarantee you that you enjoy doing trinomial. So R times R, R times R is R squared. So this time is R times -4 is minus 4R. 6R positive and -24. And the only thing you should do is combine inner and last, because first and inner and outer, because last stays the same, is 2R. Exactly like the original. Therefore, the factorization is this. Okay, that was only checking part. Okay, mandatory in the trinomial. Okay, then you select which one? Select. Select A, no? A. Thank you so. Okay, let me try. Stop, no more. Yeah, we have more. We have time. But stop. I want to analyze the sign problem, because it's always complicated. The sign is, we have two signs in the trinomial. We have two signs. So when the first sign, when the second sign, so you have trinomial. Suppose x squared plus bx plus c. This is plus or minus, this is plus or minus. This is the sign analysis. This is the second sign I call, and this is the first sign I call an A. Okay, so you analyze the order, the second. When second sign is positive, that directly. I know. Okay, we have same signs. What means same sign? Plus plus or minus minus. How you select this plus or is minus? Depending the sign of the first. Okay, when the first sign is positive, both positive. When the first sign is negative, both negative. So the option, si es positive or is negative, because it's the same, is determined by the first sign. According to the first sign. The logical sign. Okay? Example to understand this idea is x squared minus 5x plus 6. The factorization is open two parentheses xx 3 and 2 minus minus, no? Some students say, well, professor, wait. It's possible 6 and 1, because 6 times 1 is 6, and somehow 6 minus 1 is 5. The answer is no. The factorization is unique, only one, because when you try to adjust the sign, you see that the second sign is plus, so we expect same sign. The both is negative. Well, if both is negative, when you foil these to verification, look what happened. X squared minus x minus 6x plus 6. When you combine this, x squared minus 7x plus 6. We get totally wrong trinomial. Okay? So no, this is wrong. And sometimes happen that we have two combinations que aparent open the door. However, that is important, the checking part. Okay, the checking part is important because sometimes you can see throughout the course. I cannot cover any possibility in this example that we are doing now. Okay, now what happened when second option, when the second sign gets the first sign that you analyze, is the second, is negative. Well, that indicates also that we have different signs. What mean different signs? Plus minus or minus plus. Okay, so now you make a decision using the first sign. The first sign. When the first sign is positive, you put the positive in a bigger number. Suppose. This example, x squared minus x minus 6. Suppose this example. Actually, we did before. All right, let me see. Oh, 30. Let me change something. 30. No 6. 30. It's okay. It's similar, but okay. 30. To do another thing. 30. Well, okay. Second sign is negative. Look at that. Open the parentheses. You put the name of the variable. I know we expect different sign. And the combination can open the door 30. 30 times 1 is 15 times 2. Is 10 times 3. And it's 6 times 5. It's obvious that the combination of the word is 6 and 5 because 6 minus 5. No, 6 plus 5 is 11. But 6 minus 5 is 1. Exactly we need here. Look at that. Okay, now it's 6 and 5. I copy 6, I copy 5. I expect different sign, but the decision, what is positive, what is negative, depends on the first sign. The first sign is negative, in that case, and you assign directly to the bigger number. And another positive. Let's check in just in case, to make sure that we're doing okay or no. X squared is the multiplication of this guy. The multiplication of this guy is plus 5. The multiplication of that guy is minus 6. And the multiplication of that guy is minus 30. When you combine this and this, x squared minus x minus 30. And we come back again to the beginning. Clear the idea for the signs? Different signs, same sign. Is determined by the behavior of the second sign. And the final decision is determined by the first sign. Okay, you always assign to the big number. Bueno, this is the same, no problema. Because the same is both are negative or both are positive. Any question, guy? I promise the thing to understand this is doing example. We're doing 3,000 example. Okay. So now the rest of the time is not too much. Let's do 19 and that's it. I promise. 19 is regular again. 19 problem is regular again. How do you know? Well, because the coefficient here is 1. When the coefficient here is 1, it's regular. Trinomial. And regular is the easier option. Special is more complicated. It's another more complicated procedure. Okay. The new thing that bring me this example 19, 20, 21, and 22 is that we have two variables, x and y. But don't worry, it's the same. You temporarily ignore that variable. And you consider only the x. And you factorization like that. Open two parentheses, you copy the first variable, you ignore the second one, and you try to find the key to open the door. The key to open the door, 35 is 5, and well, it's 35 times 1, but it's 5 times 7. I suppose that this is the best combination. Because 7 minus 5 is 2. This number, no? So the combination is 7. You copy here 7 and 5, no? But now you include the second variable. This is the new thing that brings me this new problem. It contains two variables. And we have different sign because the second sign is negative. It's negative different, entonces es plus minus or minus plus, pero the clue can indicate me who is positive or who is negative, depending on the first sign gets positive, get the big number plus or minus. Checking quickly, x squared minus 5xy in alphabetic order plus 7xy in alphabetic order minus 35 y squared. When you combine this guy together, it's positive 2xy. Bring down x squared and bring down 35. This is plus because 7 positive minus 5 is positive. And we come back at the beginning. So you select the option. Let me see what option. 8 again. Okay, super. Any question, guys? Any question? Okay, let me start recording.